Okay? All right. Polynomial functions. Do you guys remember the definition of a polynomial? Multiple terms. So poly actually means many. And, oh no, I'm going to say nomial means terms. Okay, are you guys with me? Okay, so this looks really complicated, but it's not. You should get into the habit of listing your polynomial functions with the highest degree first. And do we know what degrees are? Your exponent. So when I talk about it has a degree of 2, that means its highest exponent is 2. So you should get into the habit of listing the highest exponent first, and then listing them in like reduced order. Like, so if it was a 4, exponent of 4, then an exponent of 3, then 2, then no exponent listed, and we finish with the constant that doesn't have the variable attached to it, right? So an example of this might be 3x to the exponent 5 minus 2x to the exponent 4, I don't know why I'm writing in pencil today, plus 17x cubed minus x squared plus 2x minus 3. So that would be the correct order. So the highest degree goes first and then 1 after. So if you look at this, n just represents your degree, and then everyone after it is just in order. Does that make sense? So you get to the point where you have no more variables left. I need a better pen to write with than a pencil. Okay. So n is a whole number. We're not going to deal in fractional exponents and polynomials. We're just dealing with n as a whole number. Okay? What's the difference between natural numbers and whole numbers? No, natural can't be. Whole has one extra digit. 0. So you can include 0, right? Because it's a whole number. X is your variable. It could be Z, it could be K, it could be whatever. And A to F have to be real numbers. So you can't have like the square root of -2 or anything like that. Okay? So nothing really terrible. And the behavior of the y values of the function. What do those straight brackets mean? Absolute values. Remember what those are? Only positive. They're the distance away from 0 without direction involved in it. So it's speed, not velocity.
But what I mean is they are only positive.
All right. Okay. Keep reaching for my pencil. Okay, we're going to talk about end behavior for just a second. So the end behavior is shared between odd and even functions. So you have odd functions and you have even functions. And we'll get to that on the next page. So an odd function would be the polynomial would have a degree that is odd. So give me an example of that. X to the exponent 3, x to the exponent 1, x to the exponent 13. So the degree of the polynomial, so the highest exponent, is an odd number. So we call those odd functions. Even functions? X squared, x to the exponent 4. But the degree has to be even. So the degree is the highest exponent, right? So when I talk about even functions and odd functions, I'm talking about like a whole group of them. And you guys in your mathematical careers have done odd functions and even functions. We haven't talked about them though. The linear graphs you graphed in grade 10, odd. Parabolas, even. So if you know how to graph a linear and you know the end behaviors of a linear, you know the end behaviors of all odd functions. Yep. So when we talk about end behavior, we're talking about where do the ends of the graph go. Okay? When I talk about end behavior, I'm just like, what is it doing? Right? Where does it end? Where does it start? Okay, let's look at this for a second. We're going to justify if these are polynomials. We're going to state the degree, the leading coefficient, and the constant of each polynomial function. So is g of x a polynomial function? What's the exponent on the x? Right? So we're going to go back up here. So what does it have to be? Has to be a whole number to be classified as a polynomial function. So it's no. Sad face. And why is it not? Because that's not a whole number. Okay. What about f of x?
Is it? It's like one term.
That's okay.
What?
That's okay.
Is it okay?
Yeah.
Maybe to you, but
Okay, so if it is a polynomial function, what's the degree?
4.
Nice.
It's a constant.
just, we have to do the leading coefficient first. Stop. Yes, it does, because it's going to tell you. So the leading coefficient is the one that's on the term with the highest exponent. So this is going to be 3. So my constant is 0, because there's nothing added to it. You okay? Leading coefficient. Okay, so this one's a little bit difficult, and you're just going to have to trust me. Because the absolute value of x, you apply a mathematical principle to it, and so it doesn't follow the properties of polynomial functions. So you're going to have to believe me on this one that absolute value functions are not polynomial functions. No, because remember how we flip the hump or the arms and stuff like that? So it won't follow the end behaviors. And then we'll all be confused about stuff, and it'll be bad. Okay, what about D? Yes. Okay, what is the degree of this one?
3.
The degree is 3. The leading coefficient
2.
is 2. So degree is the highest exponent, and when you find that term, that's the leading coefficient. So it's a special coefficient. And then the constant, -1. All right. So I need you guys to change this into exponential form.
Yeah. Okay. That's where -1.
Oh my god. Oh my god. Is it a polynomial function? No. So let's slide back up. Let's slide back up to the rules. Basil's what does it have to be? A whole number. Is -1 a whole number?
It happened to me, it has to happen to you too.
So whole numbers are positive whole numbers including 0. Negatives show up to what show? What do we call negatives? When do we first see them? What number family do we first see them in? Integers and then rationals. Okay, number families. I used the matryoshkas. It was a good time. Yeah, we'll do it again. Okay, polynomial function here. Yes. Can you rearrange it? Yeah. Okay. So we would want to get into the habit. What would we want to see first? That exponent of 5. So, but we can do this out of order because we're smart people. What's the degree? 5. What's the leading coefficient? -2. What's the constant?
So n is a whole number. What is n?
N's the exponent.
And then x is a variable. What's that?
Just that it has to be attached to a variable. Like you can't have 2 to the exponent 3. That's not a polynomial function. That would be a linear equation.
Does the constant matter?
To graphing it will.
Or to say if it's polynomial?
No.
Just a coefficient and the n?
Mhm.
And then absolute values are just an
Automatic no. Because we have to apply something to them, like absolute values, we apply a mathematical principle to it, and the end behavior will change. And so that gets really confusing, so it's not a polynomial function. Okay. A whole page of reading. Bruh. Okay. Can we talk about grade 10 for a minute? I want to talk about linear. That's all I hear from you guys. I thought you'd enjoy it. Can you graph that? Yeah? So what do I graph first? Y-intercept? Beautiful. Yeah? Yeah? Okay. So let's talk about that. Is this an odd or even function? Okay, let's talk about the degree of this function first. So the degree is 1. So is this an odd or even function?
So wait, just the degree?
Yep. Okay. So tell me everything you know about linear equations and their slopes. They are a straight line.
Rise over run.
Rise over run for the slope. Y equals mx plus b. You guys know a lot about straight lines. That's all I'm going to say. What is this slope, positive or negative? It's a positive slope because it's rising to the right. Everybody agree with me? Okay. So let's talk about the end behaviors of this graph. So it would start in quadrant 1, and where would it end? In quadrant 3, right? Those are where the ends of the graph are pointing. Right? Everybody go? No, this is a positive slope. Right? So, it could, yeah. Does it matter? Do you know what the ends are doing? Okay. So for a positive leading coefficient, because the leading coefficient tells me my slope, right? So for a positive leading coefficient of an odd function, you're going to start in 1 and end in 3. Okay. So then if we graph this line, yep. So with this new one, this red one, what's my degree? My degree is still 1. So I have a degree of 1, so it's odd. And my leading coefficient now is negative. What are my end behaviors? Start in quadrant 2, end in quadrant 4. Every odd function, so cubic functions, quintic functions, whatever the septic function is, the 7, they will all have the exact same end behavior. So if you know stuff about linear, you can apply it to cubic that you've never ever graphed before. Okay? Okay. Do we want to talk about parabolas while we're here for even functions? Okay. All right. Okay. Let's go back to the sheet. So we just did the linear. Do you have highlighters? So a degree of 1, we said it was going to be an odd function because it's a degree of 1. The max number of x-intercepts a degree of 1 polynomial can have, guess how many that is? 1. So if I have a degree of 2, what's the max number of x-intercepts I can have? And if I had a cubic function, you get the pattern, right? Like, so pretty connected. Here's the thing, ladies and gentlemen, is that it's a max number of x-intercepts. It's not always, like, all parabolas won't have 2 x-intercepts. And you guys know that because you've graphed a million parabolas. Okay, so end behavior. Line extends down into quadrant 3 and up into quadrant 1. That's only if the coefficient is positive. Everybody good with that? Okay. Let's move on to parabolas. So if it has a degree of 2, it's an even function. So it's an even degree or an even function. It can have a max number of x-intercepts is 2. You might not have 2, you might have 1, you might have 0, but the max you can have is 2. And what's the end behavior if the coefficient is positive? Our parabola opens up, right? So the arms of the parabola will be 1 and 3. If the leading coefficient is negative, what does our parabola do? It opens down. No, that's 1 and 2. 1 and 2. And then that would be 3 and 4. Okay? So if you know those two things, you can apply those exact same rules to all even and odd functions. So cubic function, degree of 3, it's odd. So same behavior. This one has a positive leading coefficient. It starts in 1, it does some funky stuff, and it ends in 3. And if we go to the quintic function while we're here, the degree of 5, it starts in 1, does some funky stuff, and ends in 3. So it follows that same behavior. We're going to deal a little bit with the funky stuff, with the x-intercepts. If you're taking calculus, this would have been super helpful to know ahead of time. So, yeah, I should have probably done this as Unit 1 to save you poor calculus people some heartache. So, the degree of 4 is going to do the exact same thing. The end behavior is going to do the exact same thing as your parabola. So, if it has a positive leading coefficient, it's going to be up in 1, or start in 1 and end in 2. Or if it's negative, it's going to be down and down. Okay, you guys know that? You good? Beautiful. Okay, this is the exact same stuff we just went over, so I don't know how important it is, but this is all summarized for you. So graphs extend quadrant 1 and quadrant 2 when the leading coefficient is positive. Graph extends into 3 and 4 when the leading coefficient is negative. That's on even degrees. Y-intercept is the constant term of the function. That shouldn't be a shocker to anybody. The degree of the function is the maximum number of possible x-intercepts, and the domain for this graph, for any of these graphs, is negative infinity to positive infinity, but the range will depend on maximum and minimum values. Odd degrees will be 3 and 1 if it's positive, 2 and 4 if it's negative. Y-intercept's it's all the exact same stuff. Y-intercept is the constant term, degree of the function is the maximum number of x-intercepts, and the domain is all reals, and the range is all reals. Do you guys know what I mean by that?
Real numbers.
All reals, all real numbers, so that would be so the nice thing about odd degrees is your domain and range is quite nice to do, and there are no maximum and minimum points. So in calculus, we calculate the max and minima on these polynomial graphs. And it's super fun. Kinda. Okay, we good? Awesome. Okay, since you guys have paid such close attention, I feel like maybe you haven't, but that's okay. I'll just stand over here and cry. Identify the following characteristics of each graph. So is it an odd and even, the end behavior, the number of x-intercepts, and whether the graph will have a max or min, and the y-intercept. Then you have to match the graph to its equation. Maybe let's start with the matching part of it. Okay? Maybe let's even back it up a little bit. Let's look at this. What do we know about this graph right here? Is it an even or odd function? It's an odd.
How do you know by looking at the graph?
End behavior, right?
And like A and D have to be graph C and D because they have 4 x-intercepts.
Okay.
So then you can just figure it out.
Yeah.
It has to be graph B because it's odd.
Okay, I just want to talk about this pretty picture for a second. It's easy. Okay, what do we know about the leading coefficient? Is it positive or negative on this one? So I know it is odd because it starts in 1 and ends in 3, and the leading coefficient, so the graph is doing this, right? So it is, the range is all real numbers, so I know it has to be an odd function. If it's 1 and 3, I know that the leading coefficient is positive. Okay? What about graph B? Is it positive or is it odd or even?
Even.
It's even. Because the arms are doing the same thing, right? The arms are ending both up. Okay, so is the leading coefficient positive or negative? It's positive. Yep. Think about your parabolas, right?
So like D can be negative because it's going down,
So D would be an even function,
but negative.
but negative leading coefficient. Okay, so now let's look at C. C is odd. And now it's 2 and 4. So the leading coefficient is negative. So just by looking at those graphs, we can decipher some stuff. So odd, and it's going to be negative leading coefficient. Now Amber pointed out that this one has 1, 2, 3, 4, 5 x-intercepts. So we know it must be at least a degree of 5. So the only one for that is C. So P of x. So this graph is P of x. Now, could a cubic function of 6 work here? Like a degree of 6? 6 wouldn't work because it has to be odd. Could it be potentially 7? Yes. But we don't have a degree of 7, so we're in the clear. Okay, how many x-intercepts does this one have? 1, 2, 3, 4. So that has to be an even. It has to be even, and it has to be a positive leading coefficient, and it has to be a minimum of 4. So D. So this one is the h of x graph.
Can we just tell that as y-intercept?
Oh, look at you. Yes. Okay, so Terse said, hey, can I just look at the intercepts here? That's another way we could have done it, but it's not very helpful learning the degrees in the end behavior, Terse, just for the record. You're ruining my fun. You're ruining my fun. So what is A? Which graph belongs with A?
B, or no, like A is D and B is A.
No, D is B.
What?
Graph B has to be H of X.
Wait, I'm losing myself. Wait, no. A is graph D.
A is graph D. Okay. I was asking about graph A, but that's okay.
Oh.
That's okay. We were just...
Then B is graph
So this one has to be G of X. And then the last one is, this has to be F of X.
This is a nice one.
Easy peasy. Kind of. Like it's not... So we did the odd or even, we did the end behavior, we did the possible number of intercepts, the graph, maximum or minimum. So we didn't really talk about that, so let's talk about that. Odds will have no max or min, it's infinite because they go on. Remember that max and min is related to the range only. Max or min, so that's going back to like parabolas in grade 11. So because odds go on forever, there is no max or min. Well, they do go on forever.
But like only in a certain direction.
Right, but they both go on forever in the same direction. So let's look at this graph. If it opens up, go back and think about your parabolas. If it opens up, do we have a maximum or do we have a minimum? A minimum. So this graph here has a minimum. So the only place we're looking at is on even degrees. And so this graph here would have a maximum. Because all values would be less than that in the range. So max and min are only related to the range, and you only have to define them for even polynomial functions. Okay, y-intercepts. Where's this y-intercept? Look at your f of x equation. 3. So we know that this crosses at 0 and 3. So h of x, where am I crossing? Negative 12. And p of x? 0, 0. That's lovely. And g of x? Negative 4. Okay, there we go. Look at that. So we've everything from grade 10 and 11 culminates into this unit. Well, at least this lesson. It's not going to be always that easy. Can I flip the page? Is everybody good with that? Am I good? Okay. Here we go. Okay. Bank vault is built in the shape of a rectangular prism. Everybody know what shape that is? A rectangular prism. I'm looking at my desk to see if I have any rectangular prisms. Mr. Dragon's bass speaker there is a rectangular prism. So volume is related to the width in meters and of the vault doorway by the function of this. What's the volume in cubic meters if the doorway is 1 meter wide? Drop in 1 where? For W. So that's pretty... I don't know what I prefer. I don't know if I prefer you guys crying because you don't understand it, or if I prefer you guys finding it so easy that you are doing other things. Like, I'm not sure what level of crazy that I prefer. I don't know.
This guy you're choosing to not be satisfied.
No. What's the answer to this? No, do it in your head. Do it in your head. Give that brain a break. Did you say 38?
140.
I got 160, 140. I heard a 38.
54 is 126. So plus 13 is 139 plus 1 is 140. Is that right?
140? And it is volume, so what is my meters squared? How about cubed? Because we have 3 dimensions, right? Is it because I made you use your brain?
Yeah.
Okay. What's the least volume of the vault, and what's the width of the door for this volume? Why would this situation not be realistic?
It's an odd graph. Do they have them?
Well, in this theoretically, no. But in this situation, there is a minimum. And the lowest volume would be 72. Yeah, that could be the y-intercept. And what do we know about the width at this point? So if the volume is 72 meters cubed, if the minimum volume is 72 meters cubed, what would the width be? And why is that not realistic? You can't have a door that doesn't exist, right? You still need to get into said door. Could I have a negative dimension for a door? I hope not. I don't even know what that would look like. We'd have to add another dimension, and we're not ready for that. So, although this is mathematically possible, and this is mathematically possible, you can't have a door width of 0. You wouldn't be able to get into the vault, making it not a very useful place to store stuff. All right, guys, that's lesson 1. That's it. That's all. Yay.